class once what has been happened. I'll scroll back like this. So we are trying to understand the variable part, especially we are trying to understand the variable part. So when the variable part comes here, variables in Java anyway. So based on data type, the variables are categorized into how many types now? Two types. What are they? Primitive data type variables and non-primitive data type variables. Primitive data type variables will hold value. Non-primitive data type variables will hold object reference. That point to be noted and you must remember it. Sir, how to identify primitive data type variable now? The variables which are declared with byte, short, int, long, float, double, char, and boolean. If we declare any variable with these 8 primitive data types, we call it as primitive data type variable. It's a theory. How can we identify non-primitive data type variable? Sir, the variables declared with class, interface, array, and enum, we call it as non-primitive data type variables or reference variables, you can say. That's the basic points to be remembered. In Java, we had only 2 types, primitive data type variables or non-primitive data type variables. So based on the static keyword, in Java, variables are categorized into how many types now? 2 types. What are they? Static variables and non-static variables. Some are static variables, some are non-static variables. What is the definition of static variables now? The variables which are declared with the static keyword are known as static variables. Now, so the static variables means what now? The variables which are declared with static keyword are known as static variables. Static variables, other name is what now? Class variables. Why we are calling it as class variables? Sir, static variables will get the memory within the class or within the object or within the class. These static variables will get the memory within the class while class loading. To demonstrate that static variable, yesterday we took one program, demo variables 1, and we are representing the variable A in the class. It's a diagrammatical form. Let me show that once. Demo variables 1 here. Demo variables 1. In the demo variables 1, I took one variable as a static variable. The variable which is declared with the static keyword is known as a static variable. That's the meaning. Sir, I want to see the location of a static variable. Because of this reason, yesterday we took some diagram. So I represented through that program now. Demo variables 1.java is a source code. After compilation, we are getting bytecode. And we are sending that bytecode onto JVM with the support of class loader subsystem. The information, the class will come and load onto method area. So method area is the location where the class is loaded. While class loading, static components will get the memories. In that process, A got the memory and main got the memory. A got the memory and main got the memory. So because both are static. Now main method has one nature, no? Right. The main method automatically copied onto Java stack area. Automatically copied onto Java stack area. When the main method copied onto Java stack area, one separate partition is created. One separate partition is created. What is the name of that partition we are calling now? Method frame. Here one method frame. Yesterday definition not written. Today we are writing the definition of a method frame. So if you observe here, when the main method copied here, here one partition is created part of Java stack area, and where the main is loaded for execution, that partition we call it as method frame. That's a theory. Now the execution engine will detect this main and executes the program. Whenever it executes the main method now, it is taking the A directly from here and displaying it out. In the heap area, I kept one cross mark indicating object is not available in this program. In the first demo variables one, object is not available. That's the point. Then I took second program now. Whenever I want to take a second program, I introduced non-static variables. I introduced the variables which are declared without static keyword. The variables which are declared without static keyword are known as non-static variables. Are known as non-static variables. These non-static variables are categorized into how many types now? Two types. What are they? Instance variable and local variable. Instance variable means outside the method, inside the method. Outside the method. Local variable means inside the method, outside the method. Inside the method. So non-static variable declared outside the method, we call it as instance variable. The non-static variable declared inside the method, we call it as local variable. Same thing I written now. The non-static variables which are declared outside the methods are known as instance variables or object variables. These instance variables will get the memory within the object while object creation. Where instance variables will get the memory now? Instance variables will get the memory within the object while object creation. Now local variables now. The non-static variables which are declared inside the methods are known as what now? Local variables, or you can say what now? Method variables. These local variables will get the memory within the method frame. I made a statement known as method frame. So method frame means one partition of Java stack area where method is copied for execution. We call it as a method frame. To represent this instance variable and local variable, I took the program number demo variables 3.java. I took it. If you observe this program, demo variables 3.java. Demo variables 3 or 2? 2 only, no? Demo variables 2.java. I took it. You can observe here. I took one variable outside the method. I took one variable inside the method. I took it. The variable declared outside the method, we call it as what now? Instance variable, memory in object. The variable which is declared inside the method, we call it as local variable, memory in method frame. That's a theory. Now this one I shown in a diagrammatical form to you yesterday. That is a second diagram here. In this second diagram now, the class is loaded onto method area. In the flow, the class is loaded onto method area. When the class is loaded onto method area, while class loading, Static components will get the memories. So only main will get the memory. B will not get the memory. Why B will not get the memory means it is a non-static variable outside the method. By terminology, it is a instance variable. Got it right? Now, in the diagrammatical form, only main got the memory. There is no memory for B. Now, main automatically copied onto Java stack and execution started. When the execution started here now, the first line in the main method is int c is equal to 30. Int c is equal to 30 is a local variable. Memory should be given inside the method frame. Memory should be given inside the method frame. So yesterday I drawn one box representing you. C got the memory in main method. C got the memory in the main method because if it's local declaration. So theory. Our major target by yesterday's second program demo variables 2.java is giving information about object creation. Demo variables 2 OB is equal to new demo variables 2. Demo variables 2 OB is equal to new demo variables 2. Now here RHS executed first, LHS executed first. RHS new demo variables 2 executed first. When new demo variables 2 is executed, new keyword is available no? In Java, new keyword represent object creation. So in that process, execution control will go to heap area and create one address location first. By terminology, we call it as object reference will be created. This is object reference. After object reference created, at this object reference, one small storage is generated. Means one small memory generated to accommodate the memory for B. Sir, why you are accommodating the memory for B? Because B is a instance variable. It has to get the memory within the object. So B got the memory. We are imagining B got the memory in the object. The object will have one object reference. The object reference will be copied onto OB. All of you understood this statement now? So OB is holding the object reference. So this is object creation process. When we want to access the variable B, we have to access with the object name. OB.B you have to access. All of you understood this point now? Whenever you want to access C, you can access C directly because C is available here, but B is available in the object. You have to access with the object name. By yesterday's two diagrams, I represented class variable got the memory in the class, instance variable got the memory in the object, local variable got the memory in the method frame. Only two diagrams I drawn yesterday to you. After that, I given one small information. Based on memory location, the variables in Java are categorized into three types: class variable, object variable, and method variable. There I stopped it, right? Okay. I asked you to try one assignment. Few people shown that assignment, what you tried. So what is the imagination you got it, you tried it. Okay, right? So today's class is nothing but, actually today I must go with queries and repetition, generally, revision. But one small part is pending. So let us write the notes on that part and complete that part and let us go for revision once again. Got it right? So that part is nothing but make a heading methods in Java, star mark IMP, methods in Java. Methods in Java. Methods in Java. Methods are the actions which are methods or the actions which are performed to generate results. Methods are the actions which are performed to generate results. Based on static keyword, the variables are the methods are categorized into two types. Based on static keyword, the methods are categorized into two types. Static methods and non-static methods. Static methods and non-static methods. These non-static methods, you can call it as instance methods. So non-static only one type. Local methods will not be there. So non-static methods are nothing but instance methods. Now static method will get the memory within the class or within the object or within the class. Non-static method or instance methods will get the memory within the object. 100% that only. Static keyword is there means class. Static keyword not there means object. Now make a shading. Static methods. The methods which are declared with static keyword. The methods which are declared with static keyword are known as static methods. The methods which are declared with static keyword are known as static methods. Are known as static methods. Other name is class methods. Other name is class methods. Static methods, or you can say class methods. These static methods will get the memory within the class while class loading. These static methods will get the memory within the class while class loading and can be accessed with class name. Accessed means executed. You can call with the class name because methods are available in the class. You can call with the class name. The static methods will get the memory within the class while class loading and can be accessed with the class name. So structure of static methods. Structure of static methods. Structure of static methods. Structure of static methods. Here, static keyword will be there. Return type will be there. Method name will be there. Parameter list will be there. And this is method body. static, return type, method name, and parameter list. Sir, I don't know parameters, sir. I don't know return type, sir. Means you have to wait it. The notes will be given return type, non-return type, with parameter, without parameter, that specifications will be given to you. So structure I am writing to you. Now static method available in the class, it can access the class variable directly. So coding rule means rule. We write it as a rule. You write it as rule like this, rule. Static methods can access static variables directly. Static methods can access static variables directly. Why it can access directly means because variable and method available in the class level. Imagination not coming means I'll draw the diagram and show anyway. Static methods can access static variables directly, but cannot access instance variables directly. Cannot access instance variables directly. Cannot access instance variables directly. The rule you have to remember it. Static method can access static variable directly. It can access. It cannot access instance variable. The reason I'll show to you through diagram. Now, types of static methods. Types of static methods. Static methods are categorized into two types. Built-in static methods user-defined static methods. Built-in static methods and user-defined static methods. Built-in static methods and user-defined static methods. Built-in static methods and user-defined static methods. So built-in static methods. The static methods which are already constructed and available from Java library. The static methods which are already constructed and available from Java library are known as the static methods which are already constructed and available from Java library are known as built-in static methods, or you can say predefined static methods. Predefined static methods. So many people are asking recordings and recordings are not available. Recordings are stopped. Online students especially, recordings are not available. That 8 recordings are the last recordings. They will not give the recordings to you. All of you clear? Online people especially. That 8 recordings I loaded, 6 or 7 I loaded, no? How many I loaded into Google Classroom? 6, I think. So 8 recordings, if not 8 only, they provided 8 to me. That 8 recordings will be loaded. 8 or 11, 11 is, something is there. Let me cross check. So how many recordings means? Total 11 recordings and 11 days. 11 session recordings will be there. After that, recordings will not be given to the students. 11 recordings I'll upload today. After that, recordings will not be given. It has been stopped already. Okay, right. So predefined static methods. Built-in means already available. We call it as built-in. User-defined static methods. User-defined means we are constructing the static method, the static methods which are the static methods which are defined by the programmer. The static methods which are defined by the programmer are known as user defined static methods. User defined static methods. Other name to it is custom static methods. Custom means constructed by the user. Custom static methods. Custom static methods. Examples of built-in many will be there. User defined, we are going to construct it. Built-in will come. In the future, we are going to use many built-ins. Just definition is coming with the category. Okay, right. Built-in many, total libraries built-in only. String methods are there, wrapper class methods are there, scanner class methods, lot more. 90% built-in only will come. Right? Okay. Now, so these are about your static methods definition generally. Static methods are in the class, in the object, in the class. Static method can access static variable because both are available in the class only. No, they can access. That's the point. So now comes your non-static methods. Make a shading, non-static methods. The methods which are declared without static keyword are known as non-static methods. The methods which are declared without static keyword are known as non-static methods, or you can say instance methods. In real-time market, they use a term known as instance methods, or you can say object methods also, because they'll get the memory within the objects. You can say object methods. You can say object methods. These instance methods will get the memory within the object while object creation. These instance methods will get the memory within the object while object creation and can be accessed with object name. And can be accessed with object name. Can be accessed with object name. These instance methods will get the memory within the object while object creation and can be accessed with object name. Because they are available in the object, access with object name. That's the meaning actually. Now, structure of structure of instance methods. Return type, method name, parameter list, followed by method body. Return type, method name, parameter list, followed by method body. So static method means here static keyword is there. Non-static means static keyword not there. Now, rule. The rule here. Instance methods can access both variables. Can access both variables, which means can access static variables and instance variables directly. Instance methods can access both variables, which means can access static variables and instance variables directly. Now, types of instance methods. Instance methods are categorized into two types. Built-in instance methods user-defined instance methods. Built-in instance methods and user-defined instance methods. Built-in instance methods and user-defined instance methods. As if like static methods, here also some from library, some we have to define it. That's a category. Same definitions will come. Same definition. The instance methods which are already constructed and available from Java library. Java library are known as built-in instance methods. User-defined instance methods. The instance methods which are defined by the programmer are known as user-defined instance methods. So this is the notes about methods, theoretical notes. Right. Based on these notes now, yesterday I given one assignment, no? That assignment solution is for this actually. Without notes, I given the assignment actually. So how much imagination will come? I checked it actually. Right? Okay. Actually, this is the notes. For these notes, that example program actually. But before giving the notes only, whether student can identify class level, object level, idea will come or not, I checked it actually. Right. Now I'll write that program. Yesterday's program is then no M1, M2, A, B. So that program is an example for this notes now. The point, right? Can I start program now? Right. Okay. Notes is for reading. That built-in methods I'll introduce slowly. I'll introduce. Okay, right. Now this is the first time I must present the notes now because variable notes is there. Method notes for reading for this week. You have to revise it in reading by Sunday, everybody. Okay, right. So example is nothing but this solution. Construct the following later. There is a solution actually. So example for above solution indirectly. Now see that. Let me show that once and observe it how I am typing. I only given a class name yesterday. I only given the class name. Actually, I took the class name as demo variables 3. See, I am taking. Close it. See that I am opening this. I asked you to type in edit place. Anybody tried in edit place? Raise your hands. How many have you tried? Very good. Anybody typed in notepad? Raise your hands. No problem. You can use notepad also. Sir, I am comfortable with notepad means you can use notepad. Nothing wrong. 1 or 2. Because next week by Wednesday, I'll change that into Eclipse anyway. So if you want, because when any examination is there, coding examination, in that Eclipse ID not there in the laptop means you must know how to do in notepad, how to do in edit place. You must know that modes, 1 or 2 modes, you must know. Because I asked you to try with edit place. Okay, right. Anyway. Now, I am opening the edit place. See there? This is the icon I had it. Opening edit place. Whenever you open the edit place, search for your folder here. E drive. In that demo 133, our folder only. Anyway, demo 133. So click on file, new and Java. Anyway. If you are not understanding anything, what you will do? Sir, I am not understanding what you will do. Open the notebook and read it. Because rules are there. Above 1 or 2 demo programs will be there. You have to follow them. Suddenly you cannot think by your own. Okay, right. Some node source will be there. If not, already written program will be there. From that you try it. Now I am taking demo variables 3. I am taking. Okay, right. According to the diagram, I must take one variable A. I must take one variable B. A, I want to take instance variable. B, I want to take a static variable. See there. Int A is equal to 10. I took it. As I given in 10 only, no, directly. Now, this variable is outside the main method. Anyway, with static keyword or without static keyword? Without static keyword. By terminology, we are calling it as what now? Instance variable memory. So memory in class or memory in object? Memory in object. Always imagine the location. If you are not understanding the location, you must ask me. Okay, right. So always one component is there means you must imagine the location. So I took one variable static int b is equal to 20. I took it. Here static keyword is there? No, right. Static keyword means static variable. Static variable memory in the class or memory in the object? Memory in the class. So static variable memory in class point. Two variables memories you are imagining already, right? So newly I am bringing a method now. I am bringing one method. So see there. What is the method I brought it now? Void M1. I only asked you to type as it is, right? Okay, right. I only given this method to you. So here, actually how this method came means, now this is non-static method. Means what? Instance method, no. Yesterday the term not there, so I not written that. So it is nothing but instance method it is. It is nothing but one instance method. Now, instance method signature is available now here. Structure is there now here. Is the structure or not now? See there. The structure, I'll copy here. The structure, I'll copy here. Now look here. I asked you to take the method name as what now? M1. I asked you to take the method name as what now? M1. Now, parameters are not available, sir, because in your diagram, nothing is there. Empty is there or not now? So, no parameter. So, return type, I don't know, sir, but you given void. Void means return type or non-return type. Return type or non-return type? Non-return type actually. Sir, I don't know that other languages means leave it. You write just void and come forward. Write void. So void M1. So in this body, I am printing something. I'll keep a message now. So system dot out dot print ln. So I am printing from instance method M1 means the answer is coming from instance method M1. The answer is coming. Okay, right. Now I am asking this M1 to display A and B. To display A and B. I asked you to display A and B here actually. Display A and B. I asked you to display it. So print A, print B now. So here I am writing system dot out dot print ln. The value of A is equal to plus A. System dot out dot print ln. The value of B is equal to plus B. Now, M1 is what kind of method now? So, M1 is instance method. Yes or no? Na? Instance method. Memory in the class or memory in the object? Memory in object. Yes or no? Right. Now, just now I written the rule now here. What is the rule now? Instance methods can access both variables, static variable and instance variable. So, M1 method is a instance method accessing A, accessing B. A is instance, B is static. So, it can access. So, no issue now. Now, I'll go for the next method. What is the next method now? M2. M2 means I took an example as what now? Static. Sir, static structure is there no, sir, with us. Static structure is there, sir, with us. This is static structure. So static structure, I am copying here. I am copying. Static structure, I copied here. Now the method name, I took it as what now? M2, I took it. Parameter not available, sir. I am removing the parameter. Okay, right. Now return type, I don't know, sir. I will take it as void. Now this is static method, memory in class, I've understood this now, memory in class. Now, I want to display from static method, system dot out dot Print ln. So static method M2. Static method M2. I asked you to display A and B. I asked you to display A and B as to display. So I am printing A and B. So any error will come. How many of you are saying yes? Raise your hands. Right. Very good. What is the rule now? Static method cannot access instance variable. Very good. Errors means error coming means developer not to follow the rule. Understood this point now? So I not followed the rule. The rule is nothing but see there. There. Where is it? Static method rule. Static methods can access static variables directly, but cannot access instance variable. Now M2 is accessing the variable A, no, error should come. Now A belongs to class A, A belongs to object A. A belongs to object. M2 belongs to class A, M2 belongs to object A. M2 belongs to class. Now M2 is in the class. Got it now? This is class location, this is object location. Always I'll show two hands in the class now. Right. This is class, this is object. In the class M2 is there. In the object A is there. Class cannot access object. Understood this point now? Object can access class. Object can access class because object came from the class. Class cannot access object. It cannot access because class did not came from the object. Because of this reason, class method cannot access object variable. Line number 14, error will come. Let me show that error to you, then I'll remove that line. Okay, right. So I violated the rule here. I am accessing one non-static variable or instance variable with static method I am accessing. Got it right? Now, after this coding has been completed, sir, line number 14 is error. We decided. Okay, right. Go for the main now. Main means execution point, no? Right. Execution point. In this execution point here, main. Whenever the main is there, is the diagram? Main. So main is the starting point. Execution starts from there only. Now, I must call the method M1 for execution. I must call the method M2 for execution, right? I made one statement when I'm giving a notes of JVM architecture, Java stack area where methods are executed. The first method copied onto Java stack area is main method. The main method will call remaining methods for execution. I made a statement. Main method will call remaining methods for execution. I made a statement. So main has to call the remaining methods M1 and M2. Now M1 is available in the class A, M1 is available in the object A, M1 is available in the object. Call with object name. Understood this pointer now? Call with the object name. Now M2 is available in the class A, available in the object A, available in the class. Call with class name. I written the notes now just now. The static methods will get the memory within the class, access with the class name. Non-static method or instance method will get the memory within the object, access with the object name. I made a statement or not now? That we have to follow it. See there. How to create object now? What is the syntax of object creation? Class name, object name is equal to new class name. We have to create object for which class now? Demo variables. Demo variables. I have to create object. See there. Demo variables 3. Demo variables 3. OB is equal to new demo variables 3. This is object creation or not now? If I want to access M1, I must access with object name or not now? What is the object name here now? OB. What is the syntax now? OB dot M1. Yes or no? Na? Right. You must access with OB dot M1. Sir, this is instance method call. Dot in Java represents what now? Belongs to. So M1 belongs to OB. Call M1 for execution from OB. If I want to call M2, M2 is in the class now. You must call with the class name or not now. What is the class name now? Demo variables. Demo variables 3 dot M2. This is a static method call. Static method call. All of you understood this now, right? M2 belongs to demo variables 3. By seeing the program, some people will not get imaginations. The reason, the mind control sometimes will not be there for the student. They need proper training. Because of that, we draw the diagrams and show the locations where they are available, from where you are accessing. We are going to draw. Here also I'll show the location with the diagram to you. Okay, right? Now save the program now. Click on File and Save. We have to save the program which location now? Demo 133. You have to save in a correct location. If you don't save in a correct location, class not found will come. Because location problem, name problem. Two. Then main could not be loaded. The answer is coming means main could not be loaded means location problem or spelling problem, saved spelling problem. So I am saving with what now? Demo variables 3 dot Java. Click on save. The program is saved. Now let me compile this program. Line number 14, error should come. Go to the folder. Go to the saved folder. The saved folder is in E drive, demo 133. Let us go for demo 133. Type CMD here. Type CMD and cross check it is opened in your folder or not. Because program is saved there now, we are in the demo 133. What is the command for compilation now? Java C followed by demo variables 3 dot Java. See, the compiler will show one error to me. Shown one error or not now? Line number 14, you had a error. The reason, non-static variable is giving a reason to me. Non-static variable cannot be referenced from a static context. It cannot be referenced from a static context. That is the error. All of you understood this? Right. Okay. Now what I should now? Line number 14, you remove it. I commented. Commented means I removed from your compilation process. Now let me recompile the program once. Java C followed by demo variables 3. So now program is correct, no? Dot class file will be generated. So Java demo variables 3. The answer is coming or not now? M1 is printing A and B. M2 is printing only B. All of you got it now? Now the same program, I will load it onto JVM. Observe it, the locations. Where the static members are there, where the non-static members are there, why that static member not access the object variable, you're going to observe it. Got it right? So this is the program output of demo variables 3. Got it right? Now, the program, I took it. So demo variables 3 dot Java, I took it. I am drawing one execution flow to you. So how many dot class files will come in this program now? How many dot class files will come? Only one. What is that now? Demo variables 3 dot class file will come. Sir, only one demo variables, demo variables 3 dot class file will come. Can I start the diagram? Right. Don't write, observe it, what I am drawing, right? Because why the static method not accessing instance variable? You have to find it. Okay, right. See there. Anyway, the main method is loaded here. Right. Now, I am taking 3 locations for demo. Method area where class is loaded. Method area where class is loaded. Method area where class is loaded. Heap area where objects are created. Heap area where objects are created. Java stack area where methods are executed. You can say Java stack area. So this diagram is important because static members are there, non-static member. Variable is there, method is there. All are said, no? Right. Okay, right. Now, the class will come and load onto method area. The class will come and load onto method area. What is the class name loaded here now? Sir, demo variables. Demo variables 3. Demo variables 3 class came here. Already you know, no? While class loading, static components will get the memories. While class loading, static components will get the memories. Right, see there. In this program, A is non-static, B is static, M1 is non-static, M2 is static, main is static. Some are static is there, some are non-static is there. Observe not now. Now A. A is non-static and instance, no? So A will not get the memory. A will not get the memory here. A will not get the memory. All have understood this point now? A memory not available in the class. Okay, right. Now B is coming. B is static, no? Right. Static variable memory in the class. So B will get the memory in the class. B will get the memory in the class. So 4 bytes memory. B is equal to 20. B will get the memory in the class. All have understood this point now, right? All have understood this A and B? Clear, right? Now, M1 is coming now. M1 is what kind of method now? Instance method. So memory in the object means what? Memory not available in the class. So M1 memory not available in the class. M1 memory not available in the class. Now, M2 is coming now. M2 is static and non-static and now static. Understood this point now, right? M2. So M2 will get the memory. M2 will get the memory. M2 is a static, no? Will getting the memory within the within the class. Void M2 got the memory in the class. Next, main now. Main is anyway static, always static. Why means if we remove the static keyword, it will not start the execution process. So always it should be static. Now main got the memory in the class. The main got the memory in the class. Public static void main will get the memory. Now loading completed. After loading, after class loading, who got the memory now? B got the memory, M2 got the memory, main got the memory. Among this, main has automatical feature loading automatically onto Java stack area. Only main will load it. Now main will go and load onto here. The main will come and load onto here. The main will come and load onto here. So main has that nature. Main automatically copied onto Java stack. This main will come and load here. Main automatically copied onto Java stack. Here, when the main copied here, execution engine will come there. That is a flow, no? Right. The execution will come there. Moreover, when the main copied here small partition created. One small partition created. We are calling it as method frame. We are calling it as what now? Method frame. Still definition not entered. Okay, right. So here main came here. Inside the main lines are there, no? Right. What is the first line available in the main now? Sir, demo variables 3 OB is equal to new demo variables 3. That is the first line or not now? First line is the object creation line only, no? Right. See there. The first line is executed here. The first line is demo variables. Right. Demo variables here. Demo variables 3 OB is equal to new demo variables 3. Already you know, no? RHS executed first, LHS executed first, RHS. In RHS, new keyword is there, no? Right. New keyword means first address is created. First one address is created here. One address. By terminology, we are calling it as object reference. Created, no? Right. Now, at this address location, one storage is created to accommodate non-static members. What are the non-static members available in the class now? A and M1. So that A and M1 will get the memory. So A will get the memory here. A is equal to 10. A got the memory. M1 will get the memory. M1 will get the memory. Void M1 will get the memory. So A got the memory here. M1 got the memory here. A got the memory. M1 got the memory. I am giving number for this object creation. So A got the memory and M1 got the memory. Now this address after object creation, this address will be loaded onto OB. Yes or no? OB is loaded with address. This is our object creation. After object creation, what you observe here now? Sir, static components B and M2 and main, they got the memory in the class. Right? And while object creation, variable A, method M1, non-static components got the memory in the object. That's a theory. Now I must call the methods now. Whenever I want to call the methods for execution, I want to call M1. Already you can see the diagram now. M1 memory available in the object. So you have to call with object name. That only concept. I must call with object name. ob.m1. I am calling the object name. I am calling or not now. Because M1 memory available in the object OB, I am calling with OB. So whenever I called this, see there, I called this M1. I'm drawing the arrow. First time I'm drawing this transition, observe it. I am calling M1. Now, M1 will come out. I said no. Java stack area is execution area. All methods should come there only. So M1 will come there. So M1 will come and load on the top of main method. That only concept. M1 will come and load onto the top of main method. M1 will come out. Void M1 will come out and load for execution here. That M1 will come for execution here. I'm giving the number as 4. All of you understood this point? Say yes or no to me. The method came from the object for execution. Whenever it came here now, here separate partition is created. Every method will get separate partition. Separate partition. Separate method frame will come. Separate method frame will come. Separate method frame for the M1. Right. Inside that M1, I am printing A and B. I am printing A and B. I am printing A and B. A is equal to 10, I am printing. B is equal to 20, I am printing. A and B I am printing. That only I am printing or not now? A and B. Observe this, right? Right, observe it. Now, while execution, see there. Now this M1 method came from the class, came from the object. Came from the object. Came from the object means it came from object. That's the meaning. You called from object. For execution, it came from object. Got it right? Now, whenever the M1 method came from object now, it want to access the variable A. Whenever it want to access the variable A, M1 method will go and check in the object. Sir, why it is checking in the object? Because M1 came from that object only. I will check in the object. Understood this point or now? In the object A is there? No. So answer will come. All of you understood this point? Right. Now M1 is saying that I want to print B. Okay, right. Whenever you want to print B now, go and check in the object. Why in the object now? Because M1 came from the object only. Now, sir, inside the object, B memory not there. Then what happens, sir? When the B memory not available in the object, execution control will go to the class. Sir, why, sir? Because object came from the class. All of you understood this point now? Object came from the class now. If it is not available in the object, we are going to search in the class. All of you understood this point? All of you? Yes or no? Now, instance variable can access static variable directly. Why? The question is there for you. Interview question is there. Because instance method is in the object, static variable in the class. How you are accessing? They'll ask it. Then you must say, instance method will come for execution from the object. The process, instance method will look for the variable in the object. If it is not available here, look in the class because object came from the class. If it is not available in the object, you have to look in the class. Because of this reason, instance variable can access static variable directly. All of you understood this point? Right. Okay. That is a rule came out. So answer is coming. So instance method can access both variables, object variable and class variable. After execution has been completed, M1 execution has been completed, answer came. After execution has been completed, automatically the method frame will be destroyed. from the Java stack area, whatever the method frame created, it is auto-destructed. It is automatical. It is a rule of Java stack area, auto-destructed. Understood this point now? Once auto-destruction completed, execution control will come to main again. It will come to main. Whenever it comes to the main now, next line is waiting now. What is the next line now? This line completed. Now I'll go for the next line. Demo variables 3.m2 here. Demo variables 3.m2. Now I am accessing the method from class. What you are saying now? M2 belongs to demo variables 3 now. So you have to access the method from the class. You are accessing from the class or not now? See there. I am calling from the class now. Because you written M2 belongs to class, you said. Now the execution control will go to class directly without looking into object. Because you said belongs to class, no, it will go to the class. From that class, I'll bring that method outside. From that class, I'll bring the method outside. Now the method is coming out. The method is coming out. Void M2 method coming from the class. Method coming from the class. The transition 5. Now the method came from the class, no? Yes or no? Na? The method came from the class. Point. Now it want to access the variables. A is equal to 10, B is equal to 20. For you, A is equal to 10, access not there, no? Yes or no? Na? Why access not there? I'll show it. See there. The method came from the class or came from the object? Came from the class. Whenever it came from the class now, I will look for the A in the class. Yes or no? Na? Because I came from the class or not now? I'll go for the class. In the class, A memory available or not available? Not available. Then the control will not go to object. Understood? Because I came to the class now already, I will not go to object. Because of this reason, static method cannot access instance variable directly. In the process of executing static method, the execution control will go to class directly. Where instance variable memory not available, compilation error. Compiler know the rule. It says you cannot declare. All of you understood this statement now? A memory is not available in the class. So for you, access not there. In the coding rule, for you, permission not there. You can access the B, no, right? Very happily, you can control, go to the class. In the class B is there. Answer is coming or not now? It's coming. All of you understood this? Right. After execution has been completed now, this method frame destroyed. I must draw the method frame here. This is separate method frame. So this method frame is destroyed. When the method frame destroyed here, execution control will come to the main again. Execution control will come to the main. Whenever the execution control come to the main, lines completed, no? Yes or no? When the lines has been completed here, this also will be destroyed. Main also execution completed, no? Once main destroyed, automatically JVM machine shutdowns. All of you understood the flow now? Yes or no? Main method first comes to the Java stack area automatically, and the main method will call remaining methods for execution. How it is calling now? If the method is in the class, call with class name. If method is in the object, call with object name. All of you got this theory? Right. How can I know it is in the class side, is in the object now? Static keyword is playing a role or not now? Right. So methods only two types. Third method not there. If anybody says third method, ask the memory. So only two methods. One method will get the memory within the class. One method will get the memory within the object. Third method naireta. Not available. Third method is not available. If anybody says third method, core Java trainer said one method got the memory in the class, one method in the object. If we say third type of method, show the memory where it is available. So third memory not available for the method. All of you got this point now? Only two methods are there. Coding rule very easy to remember. Static method can access static variable directly because both are available in the classes. No, it cannot access instance variable, but instance method can access both variables, static and instance variables. All of you got it? Right. Okay. So in this week, finally, you got the notes on variables and methods. Observe this point or not now? So complete reading, revision is missing, but Monday revision is there. First 30 minutes revision. Variable methods, total revision will happen first 30 minutes on Monday, right? Now assignment is not available to you today. So read the total notes and adopt all this concept and come on Monday. So Monday onwards, we are going to move the course forward. All of it clear and comfortable for this week? Right. So read the notes. So reading notes is only crucial thing because every rule I am giving in the notes, everything will be there. Everything will be recorded there. Total recording is available in the notes to you. Moreover, the notes is a running notes. I am only typing the notes in a live class to you. So read the notes whenever you find time. And I'll add this program and diagram in your Google Classroom. If anybody not joined still, so contact these numbers and put a WhatsApp messages and join the Google Classroom fastly. Got it right? Can we take a break for this week? Right. We are meeting on Monday. Okay, right. Thank you very much for this week. Take a break.